All right, so we're going to do 1.8 today, 1.9 tomorrow, and then Wednesday we'll have a quiz over 1.5 through 1.9. And then Thursday we're going to do 1.10, which is word problems, everyone's favorite. So I know. So we'll do the work for 1.10, and then I think Friday is just going to be more practice on 1.10. And then Monday next week I'm going to give you class time to work on the review. And then Tuesday will be the review, Wednesday will be your test. So that's kind of the next week and a half at a glance. Yes?
I will not be here tomorrow.
Okay.
I will not be here tomorrow.
Yeah, just so you know, I always record, so if you miss, it's your responsibility to catch up on your own. So you've got access to what everybody else has access to. So.
Oh, question.
Yeah.
Am I gonna need anything for the 13th through the 16th?
Off the top of my head right now, I don't know. I'd have to look. I need to work on teaching right now. So, okay. Today we're going to talk about solving absolute value equations and solving absolute value inequalities. Okay? Absolute value, if you remember, absolute value, the definition is the distance a number is from 0. Okay, so the number in this case is still 9 units, even though it's -9. And it's 9 units if it's +9. So this would be how I would write this expression. Absolute value of x is equal to 9. Absolute value of what number is 9 units away from 0? Well, the answer is either -9 or +9. Does everybody see that? If we add something a little more complicated, like this, what this is saying is what number, when I add 4 to it, is 11 units from 0. So if this is a -11 and this is +11, well, what number plus 4 is +11? What number plus 4 is +11? 7. And what number plus 4 is -11?
-15.
-15. So absolute value equations always have 2 solutions. Say that again, because one of you on the test will tell me there's only one answer. Absolute value equations always have 2 solutions. Okay? And the way we solve absolute value equations algebraically is we recognize if this is equal to 11, that means that x plus 4 must equal +11, or x plus 4 equals -11. So I will always set up 2 equations when I'm solving absolute value. My first equation, I just drop the absolute value sign and write it the exact way it's written. How about everybody turn their Chromebooks around for me? So I feel like a lot of you are working ahead or working on and when it comes to this, you aren't going to know what to do. So I'd appreciate if during the first 10 minutes, everybody just pays attention, and then you can get to work after that, all right? Okay, so the first thing I'm going to do is set up one equation where I drop the absolute value sign, and I just write it the exact way it's written. My second equation, I drop the absolute value sign and set it equal to the opposite.
So you never switch in the forms, isn't it? You never change.
No.
Okay.
The only thing I'm changing on the equation is what it's equal to. I'm making what it's equal to positive, and what it's equal to is negative, the opposite sign. Now, if you ever get a problem like this, do not just skip ahead and jump and say, okay, I've got to make 2 equations. My first one, I just drop that. I make it x plus 4 equals -11, and my second one, I drop it, and I make it x plus 4 equals +11. Why? Does that not work the same way?
That should. Because
It would have
it should
to be
equal
positive.
or it should equal 2 different numbers, but
It should. Is it ever possible a distance is negative?
oh no.
Oh, so there would be no solution.
No solution here. You will never have the absolute value of a number be a negative number. And that's what this is asking. What value, when I add it to 4, will be negative 11 when I take the absolute value of it? Does not exist. Okay, so this is a trick question. If it's ever set equal to a negative, do not just jump into the routine of drop the absolute value, set it equal, drop the absolute value, set it equal to the opposite. It only works if the original setup is set equal to a positive number. Everybody clear on that? Okay, so not too hard of a concept because we understand both are going to be equidistant from 0. Both are going to be 11 units from 0 in this case. Okay, the only difference between this and when I'm dealing with inequalities, same thing for the first one. Drop the absolute value, write the inequality exactly as written. Okay, so if this is how it started, I'm going to drop the absolute value and write it exactly the way it's written. But the thing that's important here is what I'm really doing. Let's go back to this equal. This might make more sense to you. For the second equation, what I'm doing is saying that the opposite of this is equal to 11. And when I divide through by negative 1, everybody see there's a negative 1 here? That's where I'm getting the negative 11. So if I set this up with an inequality, well, what happens when I divide through by negative 1? Flips the sign. Okay, so it's a two-step process. With inequalities. First inequality, you always have to set up 2. Drop the absolute value, write it exactly the way it's written. The second inequality, you drop the absolute value, flip your sign, and make it negative.
Just the end?
So these are the two inequalities I would solve for this inequality problem, absolute value problem. Then after I've set it up, I can see that x is less than or equal to 7. And here, x is greater than or equal to negative 15. Okay, this is a less than sign, right? So absolute value inequalities with less than signs, when I graph them, this is going to be greater than or equal to negative 15, less than or equal to 7. So it's the space between, which makes it an and inequality, an and. It's both of them. Okay? So what you might think when I switch this to greater than or equal to, this becomes greater than or equal to here and less than or equal to here. So when I graph that, I flip these. Greater than, less than. It can't be both. It can't be both greater than 7 and less than negative 15. So this is an or inequality. Okay? There was a question on the textbook check on whether if it was some absolute value with a less than sign is an and. That is true. You really don't have to memorize that. Because as soon as you graph it, you can see it. Right? As soon as I graphed the solution when it was less than, I saw that it was between the two. So I know that's an and. As soon as I graphed it when it was greater than to start with, I see it's an or. So I know after I graph it whether it was an and or an or statement. Okay? Just as a review, interval notation, that's how I would write that. Okay? Interval notation here. That's how I would write that. Everybody remembering interval notation? Because you'll have to know it for this section too. Okay, so to do these problems, the key here is to remember you will always set up 2 equations. You will always set up 2 inequalities, depending on whether it's an equals or a less than or greater than. And to find those 2, the first step, drop the absolute value, write it just exactly the way it's written. For an equation, second step, drop the absolute value, change the sign on the after the equals. If it's an inequality for that second step, drop the absolute value, flip the sign, and change the sign. Or flip the inequality sign and change the sign of what it's less than or greater than. Okay? All right. That is it.